Okay, so we're going to continue on here with our unit on circles. And today we're going to look at central angles and how that compares to the arc measure of the arcs that are created by them. So we will get into arc length later. One thing that you are going to have to remember here is that arc measure is it's a number of degrees, and it's kind of how much space in degrees the arc is taking, whereas arc length is how far you would have to walk around that part of the arc. And we need to use things like, units and measurements there. Whereas with the arc measure, we could have two circles that have wildly different circumferences, but they could have two arcs that have the same measure, that look the same, that just don't have the same length. We'll get more into that later, but I just want to distinguish that right at the start. Okay, so let's define central angle again. You've got this definition on the front page of your notes here, or I guess it's actually maybe page 2, I don't remember, somewhere on that dictionary. But a central angle is an angle with its vertex at the exact center of the circle. That's where the name comes from. And its two sides are radii. So that's kind of nice because we know that these two sides are going to be congruent to each other because all radii in the same circle are congruent. So as an example here, we've got angle ABC is a central angle in circle B to the left here. Now, the number that a few of you have mentioned along the way, and now we're going to see it for the first time, the sum of all central angles in a circle is 360 degrees. So if we go all the way around the circle, we do have 360 degrees worth of angles. And you can prove that. I'm not going to prove that in the video, but you can prove that pretty easily just by constructing a diameter and looking at the fact that you've got a 180 degree straight angle on both sides of the diameter. So the measure of the arc, so we're talking about in degrees, the measure of the arc formed by the endpoints of a central angle is equal to the degree of the central angle. So this is really nice. These arc measurements are actually defined by the central angles that are creating them. So 360 degrees worth of central angles means that we've also got 360 degrees worth of arcs in any circle. So if we look here on this example to the left here, if we look at minor arc AC, and I know it's a minor arc because there's only two letters there, well, this angle ABC is 84 degrees, so minor arc AC also has a degree measure of 84. Now, if we look at major arc ADC, so I'm walking around the circle from A to D to C, then that's the rest of the circle. And we know that there is a sum of 360 degrees, so that means that the measure of arc ADC is 360 minus 84, which is 276 degrees. So not too bad, hopefully. So a couple things to keep in mind. Watch out for straight lines, diameters, because those are 180 degrees. Vertical angles are very much in play, where we've got those angles across from each other that are congruent. That means that the arcs across from each other are going to be congruent also. So let's look at an example or two here. So on number 1, we want to find each angle and arc measure that it asks us to. Let me zoom in a little bit here. So the first thing we want to find is the measure of arc ST. So go ahead in the box, put the measurement in degrees of arc ST here. Okay, we've got angle SQT is given to us at 122 degrees. So that means that arc ST, which is created by the endpoints of that angle, are it's the same measurement. So it's 122 degrees. Okay, now find the measurement of minor arc RS right here. So we're looking at RS. Okay, so we do have a straight line here. We have a linear pair, which means that these two angles need to add up to 180. So we need a 58-degree angle here on angle RQS to make a linear pair with angle SQT. But if that angle is 58 degrees, then what that means is that the minor arc, RS, is also 58 degrees. Okay, and then the last one here, let's look at major arc, SRT. So we're traveling from S down to R, and then all the way around to T. So there's a couple ways you can do this. One way would be to take the 360 and subtract away 122 degrees. If I draw this in here, so we're looking at arc SRT, so this one right here. So this is the entire circle besides this 122 degree arc. So we could totally just take 360 minus 122. Another way that we could do this is to look at the fact that RT is a diameter, and that means that this arc from R to T, even though we don't have a middle letter here, is a semicircle. So I could take 180 degrees plus this 58 degree angle here. Either way is going to get me the same answer. So let's see, 180 plus 58 is going to get me a 238 degree arc measure. Okay, let's do one more together here. Okay, so let's go ahead and do number 2 together. So the first thing we need is the arc measurement of JK right here. So go ahead and put that in the box. Okay, that's defined for us already as 21 degrees, so nice piece of cake there. Okay, the next thing we need is the measurement of angle JNM. So in the box, go ahead and put the measurement of angle JNM right here. Okay, so we need the supplementary pair to this 21 degree angle. So that means that the measurement of JNM is going to be 159 degrees, because 159 and 21 add up to 180, and we do have the diameter here, the straight line. Okay, the next thing we need is the measurement of arc KL. So go ahead and put that in. Okay, well, if we just figured out that JNM, maybe I'll even put this in here. We just figured out that JNM is 159 degrees. Well, what that means is because of vertical angles, this KNL is also 159 degrees. And that is the central angle that's creating the arc KL. So that means that KL, the arc, is 159 degrees. Okay, let's look at the next one we've got here, which would be arc JKM. So J, K, and then all the way around to M. Go ahead and put that in the box. Okay, so we've got JK is 21 degrees. We know that from this given central angle here. And if we look at KLM, that is actually a semicircle. So that is 180 degrees. So if we take this 21 degree arc and then we add it to a 180 degree arc, then that gets us our whole arc JKM, which would come up to, I believe, 201 degrees. Okay, and then our final arc here, we're looking at arc MKL, so almost the entire circle. We're going from M to K to L. Let's go ahead and put that in the box. All right, so there's a couple ways to do this. We can add all these pieces. We know MJ, we know JK, we know KL. So we could add 159 plus 159 plus 21. That would get you the answer. Another way to do this is by subtraction, and you're going to see this a lot. You can do addition or subtraction if you know enough information. We know that the entire circle is 360 degrees, And MKL takes up all of that except this 21 degree slice right here. So if we take 360 minus 21, we're going to get 339 degrees. We would get the same thing if we added 159 plus 21 plus 159. Either way you do it, you're going to get 339 degrees, and that is the measure of that arc. Okay, so we'll get some more practice on this in class. That's all for this video, and I will see you later.